In warehouse automation, discussions about innovation tend to focus on technology. The spotlight is usually on faster robots or higher storage density or just about anything different just to circumvent certain patterns. In many cases, however, I believe the more powerful lever is not the technology itself, so to say, but the speed at which a system can be planned and sold and implemented and brought into operation. And this is one of the reasons why AutoStore has been so disruptive. And no, I'm not working for AutoStore. And will you please admit they are a decent benchmark for a thing or two, right? There are dozens of warehouse automation companies competing in the market. Many of them offer impressive technologies and products. Yet AutoStore, which is not exactly breathtaking, with a concept that's older and more mature than most college students, has consistently outperformed many of these alternatives in the market. The obvious explanation would be that its technology is superior in every aspect, but it's not. And I believe one of the key reasons why customers choose AutoStore is the pace of project execution. Furthermore, I believe that's one of the reasons why the execution tends to go well. AutoStore systems can typically be planned and implemented far more quickly than any of the, let's call them, traditional automated solutions. Compared with a classic shuttle system or mini-load crane or other large goods-to-person systems, the technological overhead is much lower, as is the project overhead, and the path from concept to operation is significantly shorter. Exotech and, of course, AGV-based solutions also benefit from relatively fast rollout, but AutoStore perhaps is the clearest and most influential example of those systems with a commercial success, and where the commercial success is tied to how quickly it can be realized. And that matters for an important reason that is often underestimated. Faster project execution does not merely satisfy customers who want quick results, but it also reduces the delay between planning decisions and operational feedback. And that delay is crucial. In systems engineering, learning depends on feedback. You form assumptions, design a system, implement it. You observe its performance, and then you compare the outcomes with your expectations. And ideally, that is how planning capabilities would improve, because that is how errors are discovered. But when the time between design and operational reality becomes too long, the learning cycle starts to break down. And this is a common problem in warehouse automation. A system is planned and offered to the customer, negotiated internally and commercially, then sold after a month, sometimes years. For a large project, it often takes 2 years until the product is actually sold. And then it's integrated into a building, installed, tested, ramped up. And by the time the system is actually operational and its real performance can be evaluated, 4, 5, even 6 years may have passed. Not always, of course, but often enough. And that means that the people who made the original planning assumptions often receive feedback only after a very long delay, if they receive it at all. And some have changed roles or even employers. Even if the organization technically has access to the outcome, the connection between cause and effect has become weak. The planners who made the decisions are no longer close enough to the consequences of those decisions to learn from them properly. Now, that's a problem. Because of the significant delays, false assumptions survive far too long. A planner may repeatedly rely on the same weak logic, wrong or misleading analyses, oversimplified design principles like using daily averages or something like this, across multiple projects before the real consequences become visible. Therefore, mistakes are repeated. And that's how it goes. Some time ago, I attended a presentation by a warehouse engineer that I have known for a while. And listening to his presentation, I thought to myself, oh boy, he's still doing that thing. After 15 years or so in the industry, he should have figured this out. And he should have figured out this is not a good idea. But if the feedback loop is very slow, 15 years isn't actually very long. It might be no more than 3 consecutive large projects from planning till hitting decent throughput. Also, customers struggle to detect planning weaknesses early enough. By the time deficiencies become obvious, the system is installed and operational, and corrective action now would be very expensive and painful. And importantly, when some of the customer's assumptions don't hold at all, such as growth rates, customer demography, competitive landscape, the product portfolio they have in their warehouse, planning mistakes might go entirely unnoticed, since they either don't surface at all or can be explained away by reference to changed market conditions. And that's why reducing the delay between cause and effect can be a competitive advantage. If you can move from concept to operation in a much shorter time, not only can you win customers who appreciate implementation speed, but you also win because you can learn faster. Your planning assumptions will be tested against reality and much sooner, helping you identify planning errors earlier. And over time, this creates an enormous organizational advantage. Think about it this way. If you can learn faster than your competition, all other things equal, this is equivalent to having smarter people than your competition. And who wouldn't agree that's a good thing? Many suppliers claim to have completed hundreds of projects, but experience is not a matter of project count. It depends much more on how quickly you can connect planning decisions to project outcomes. If the delay is too long, even a large number of projects may not translate into learning. You may simply end up repeating the same mistakes many times at scale. Now, put differently, projects completed are not the same thing as learning cycles completed, and I think that's a very important takeaway message. A learning cycle is only really completed when a planning assumption meets reality, and the difference is understood, and the result changes what the organization does next. And this only happens after project execution, which in this industry can be years after systems engineering. A long time ago, I published an article in German only that I called der Customer Happiness Manager zur Gewinnung von Wiederholkunden, which I would translate as the Customer Happiness Manager as a way of winning repeat customers. And one of the ideas behind that article was precisely that, staying in touch with customers long after project handover to learn what works well and what doesn't. The Customer Happiness Manager can become a carrier of organizational feedback. Also, this may be one of the reasons why certain simpler, faster to deploy systems have been so successful. Their advantage is that they compress the feedback loop between idea and reality. They allow both suppliers and customers to learn faster. And in a field where where system design is full of assumptions about order structure and throughput and SKU shapes and labor interaction and replenishment and future growth, which is never accurate, faster learning may ultimately be more valuable than a marginally better technical feature or technology. And this also has implications for how companies should think about innovation. The industry often assumes that progress comes from adding functionality or sophistication and technical depth. But in many cases, progress may come from reducing complexity or shortening execution time and making feedback available sooner. A system that can be realized in 1 year instead of 2 or 3 may generate more long-term value than a, say, technically more elaborate system that locks everyone into a slow learning cycle. Now, let me share a brief anecdote. An acquaintance of mine, who's the founder of a successful e-com business, he once told me a story from the installation of their first shuttle system. During commissioning, my friend walked through the warehouse and he noticed a technician from the supplier sitting in front of one of the shuttle aisles with a laptop. There were around 30 shuttle aisles in total, and curious, he asked, "What are you doing?" And the guy said, "I'm commissioning the shuttles." Now, he was doing this one aisle at a time. Some days later, my acquaintance walked the warehouse again and saw the same guy now sitting in front of the next aisle. Now, it turned out that commissioning took roughly a week per aisle. Used to questioning accepted paradigms and with a decent understanding of technology, he was, let's put it mildly, he was astonished. And what surprised him the most was not the process as such, but that everyone seemed to accept such a slow process as normal. On that note, when I witnessed the development of a new shuttle system back in the day, I do not recall anyone talking about commissioning time. But everyone talked about features. Does it have to be roaming or not? What are the possible bin sizes, and so on. Now, reducing implementation time does not seem like a very attractive topic for sales engineers, but it can make a difference for them in the medium term, at least. And I think, I'd say most salespeople, most sales engineers never think about that. Swift implementation is not prominent enough as a feature. If we want better systems engineering and logistics, we should focus not only on more features, I think, but on faster learning. And one of the most effective ways to achieve faster learning is to reduce the delay between cause and effect. And this idea is not new. Let me just grab a book. So this idea is neither novel nor original in any way. Peter Senge, in The Fifth Discipline, treats feedback loops and delays as core building blocks of dynamic systems. And in chapter 5, he argues that system thinking is about seeing interrelationships rather than linear cause and effect chains, and processes rather than static snapshots. He also emphasizes that delays between actions and consequences are one of the main reasons systems are misunderstood and why learning is inhibited. And in his words, delays can lead to overshoot, instability, and poor decisions, precisely because people do not receive timely feedback on the effects of their own actions. And that maps quite well onto warehouse automation projects. In long project cycles, the people making design decisions are often separated by years from the operational consequences. When feedback from a decision arrives late, the relationship between action and outcome becomes harder for people to observe and to learn from. And the result is what systems thinking would predict: weak, slow learning, which in the long run harms competitiveness. And that is highly relevant to logistics systems engineering and, in my view, still underappreciated in the industry. The learning process isn't exactly working in many organizations, partly because much of the relevant systems engineering knowledge is mostly tacit knowledge, and partly because learning takes so long.